Hey everyone, welcome back. Today we will continue building our customer-facing chatbot. We'll build it with the help of FastAPI, Langchain and its RAG modules, LangWatch for observability, and we'll finally deploy it to the AWS Beanstalk with the help of Docker. Let's dig right into that. Okay, so first step to build our project is actually to set up our virtual environment. Let's create a Python virtual environment and install the required dependencies. We'll start by creating the virtual environment. We'll call it .venv. And we will activate it. After that, we can install the dependencies that we need with our pip command. We'll install FastAPI, LangWatch, Langchain and a couple of other Langchain-based packages. Let's see how it goes. Unpacking. Great. And now we can proceed to creating the .env file where we will be storing the API keys for our project. Let's do it. Now let's write some code, and let's kick it off with importing all the libraries that we need for our RAG. I can do it in simple command, just copy paste everything because I have everything prepared. As you can see, we use some basic Python libraries as OS and .env, but we also use a lot of stuff from Langchain, which will be the core of our RAG pipeline, and we also use LangWatch for monitoring. Our next step would be to import the .env file that we have the API keys accessible. We can simply do that with load.env with one simple line. Next, we can actually assign and access the API key with help of OS module. After that, we can create the LLM instance. In our case, we'll be using the OpenAI API, and we will be building around GPT 3.5 Turbo. We can simply do that in another one line. While we have our LLM, and what else can we do? Actually get the RAG prompt from the Langchain. We can literally just pull it from the hub of prompts. Okay, good job. Now let's start writing some functions for our pipeline. Our first function of our RAG pipeline would be the URL scraper. Basically, we will be scraping the information, the contents of the URL of the website that we are pasting to our chatbot. And our goal is to return a set of documents. So let's start. The simple function definition will be returning the list of documents, and our URL will be a string. And we will need a loader for that. As you can see, we imported the web-based loader from Langchain that easily loads the contents from the URL. With this web path, we get all the contents of this URL. And after that, we can actually just get that into the documents, to the docs. Though those docs will be later used by the retriever. And let's just return the docs. Simple function. Our second function of our RAG pipeline will be the create retriever function. And as you may guess, its goal is to create the retriever and return it. Basically, we'll start by simple function definition, which will get the list of documents as an input, and it will return the vector store retriever. We can also create the text splitter that we'll use to split our text into chunks. It will be an instance we'll pick the overlap of 200 and the chunk size of 1000. Those are the numbers of characters from each chunk. Next, we will get the splits. So what splits are, they are the documents split into chunks. So now, instead of just documents from the URL that we had, we'll have the chunks of those documents. And finally, we can actually just create the vector store with Chroma. And in that vector store, we'll be storing the documents, aka splits, those chunks, and we'll use the OpenAI embedding that will be our kind of vector database, but local. After that, we actually just need to create the retriever as an instance and simply return it. After that, we can also make one simple helper function to format the docs, and its primary goal will be to split it in a nicer way, split all the docs in a better way that it's stored. The last function from our rec pipeline will be actually the askRec function, where we'll be asking the questions and passing the questions to our rec pipeline that we get the answers. Let's start by putting the language decorator for observability. It's a simple line to create the trace. Next, we can define the function. It gets the question that was asked by the user, and it gets the retriever that we create above. So we'll first create the retriever and then pass it to askReg. Next, we need to define the config for monitoring with LangWatch, and we will need to get the callback functions this way to actually monitor what is happening, how our rag is working on the background. And then we will create the runnable with that, with those configurations, and this runnable will be used in our rag chain. Final step is actually to create the rag chain. As you can see, we are getting the context from the retriever, we are putting the question over there, the formatted docs, the prompt that we pulled from the hub, our LLM, GPT 3.5 Turbo, and the output parser. Finally, the answer, we can receive it simply by invoking our chain with the question. This is a question and this is the question runnable. So these are the configurations, and here's the actual question of the user. And we'll just return the answer. We'll just return the answer of the LLM. And our answer is actually a string, so let's put it there as well. Nice. Okay, let's start building our backend. We'll build our backend with FastAPI, so let's import it. Then we can also import all the methods that we just built in our rag pipeline, so we can use it here. And we can actually create the instance of the FastAPI app. Simple, one line. Now we'll create two methods, one of which will be handling the GET request, and another will be handling the POST request. The GET request method or function is super simple. It's available on the official FastAPI documentation. I'll not explain that in very detail. It just returning the message with hello world. So if you go on this URL, then you will see this message on your page. But now let's build the function that will be handling the POST request, and it will have the different URL /ask. And our function will be getting the question as a string and the link as a string. And those arguments will be given by the user. So the user will give the question and the link, and this function will be returning the response to the user. So we can first scrape the documents from the link that the user gave to us, and we can create the retriever from these documents, our vector store that stores everything in embeddings. We just built it a moment ago in rec.py. And next step is to get the response and to invoke our askReg, the reg chain, with the question and with the retriever that we just created here. And as simple as that, we will just return the response to the user. Very simple post request handling function. Hey, now let's Dockerize our application. But before that, let's create the requirements.txt file. We'll store all the dependencies there, and it will be much easier to Dockerize our app if we have this file, because we will just install all the dependencies in the Docker container with its help. The simple command is pip freeze requirements.txt. If the file doesn't exist, it will create it, so no worries. Okay, it's done. Now we can get back to VS Code, and we can start creating the Docker file. I already have some commands here. So we know that we are using Python 3.11, and we also can define the work directory in our container that will be /app. As next step, let's just copy the requirements.txt to the /app, and let's install them. Let's run pip install the requirements. It will install all the dependencies in our directory inside of the container, and then we can copy all the files that we have in our project root to this directory as well. Last step is to define the command which will be run to start the server, our FastAPI server. It starts with unicorn. We can also define the host. In our case, it's localhost, and the port where the application will be available. Also, pay attention that here you need to mention the name of your Python file where you have your FastAPI application code. So this one. All right. But before moving to any AWS stuff, let's first try running our application locally with Docker. So to do that, we have to first build the image. I'll call it DLA. And we can do that with this command. And then we can run it at the port 80 with this env file. It will be DLA. Yep. So it returned us some hash, meaning that now it started running, and we can actually navigate to Google Chrome and check it out. Localhost 80. Okay, nice. Here we see the message, hello world, that is supposed to be returned by our root get function handler. We can also navigate to docs, and we can see our two methods, our two functions over here. Good job, we can run our app locally now. Great, now we finally can move to the AWS. So first that we need to do is to set it up in our terminal, and also open the console AWS dashboard and configure it and give some permissions. Let's start with actually installing the AWS CLI. I already have it, so it shouldn't take long here, but I'll use brew for this. Okay, we see it's happening. Okay, great news, it's installed, and then what we have to do is to configure it, AWS configure, and what you will see, you will be prompted to input AWS access key ID, AWS secret access key. As you can see, I already put them here in advance, and default region name. Make sure that it is the same one that you picked on the dashboard, AWS dashboard, and the output format. I have none, but you can put something like JSON. But where to get these values? Let's check the AWS dashboard. So I went to IAM, Identity and Access Management, then to users, and created a separate user for this application. I called this user deploy LLM app, as simple as that. And now I see this little dashboard. So I have the access key one that I'm actually using, and that is the access key that I put into the terminal. I can show you how to get another one, for example. Simple description. Yeah, so this way you can get the access key and the secret access key. Don't reveal that, and I will not do that either now, but you can copy it and paste into your terminal. But besides that, what we also have to do is to give the permissions to our user. And namely, we have to give this 4 predefined permissions. Administrator access, maybe I can, no, it's still not visible anyway. For example, administrator access, AWS Elastic Beanstalk, it's this one. We definitely need to give this permission, and also EC2 full access, S3 full access, and IAM full access. But there is also an important custom permission. The way you can add permissions here by picking add or create in line, and this custom was this custom permission is this. So we have to give a permission to our user to create the environment, describe environment, and describe environment resources. This is very important for our next step, creating the Elastic Beanstalk environment that will be actually kind of a runnable of our application on AWS. Alright, and the final step is actually to deploy it to the AWS Elastic Beanstalk. For that, what we have to do is to brew install AWS Elastic Beanstalk to make sure that we can communicate with it. I already have it pre-installed, so also run quickly. And then what we have to do, we have to initialize an application with Docker, and we can call it deploy LLM app. Maybe this should work. Okay, it has been created, and an application is just one thing, but another important thing is an environment inside of that application. The environment will be storing all the API keys and will be actually the core of our runnable. So we have to create that one as well. B-in-V. And we gave our user permission to do that. So let's do it now. It might take some time. I'm sure it will. But let's see. Once we created our EB environment, we can actually proceed with setting the environment variables in that environment. I'll just give you a visual example of how you can do that. It should be this command with your API keys. Obviously those are not my real API keys, I don't want to show them, but you can see it, how to do that. And there are multiple ways how to do it again, but I prefer this one. It's the simplest, especially when I have just two API keys. So it's really easy and really convenient. And what we have to do after those are set, we can do the deployment with a simple command eb deploy. Let's do it. I think it should be quite fast. Let's see. Okay, completed successfully. So it should finish now. And after that, what we have to do is to put this command eb status. And we see that the health of our deployment is green, meaning that it's in good condition. And what we are seeking for here is this CNAME, which is basically the URL where our application is deployed. So we can copy it and go to Google Chrome, and we can navigate there. Okay. Hello world, nice. Let's go to the docs. And here are our APIs. We can actually test our APIs. So cool thing about this Swagger UI that you can try those APIs. And as an example, I love this question about the LangWatch and the concepts that we have. So we have these concepts of span and trace in conversations that the chatbots have. And let's ask what is a span, and we'll give the HTTPS docs language.ai concepts page that we want to scrape and get information from. Let's execute it. So ideally it should give us a valid response. Okay, a span represents individual steps taken to achieve an outcome, such as making calls to APIs or formatting responses. Progression of tasks within a trace. Okay, so span is within a trace. Let's now perhaps navigate to this page and try finding what is a span. Okay. Spans represent individual steps taken to achieve the outcome. In the travel bot scenario, a span could be a call to the LLM to suggest potential destinations. Wow, cool job. Great job, actually. Nice. Our application really retrieved this content from the URL, from the page, from the web page, and it gave us response based on this. It's really nice. Lastly, what we can do is actually to inspect what we monitored with LangWatch. So if you remember, we added a few lines that were adding the traceability to our RAG pipeline in our rag.py. And those few lines connected us to the LangWatch. And now we can see what message we observed. So we have the analytics. It still shows 0 messages, but we sent only 1 message. It takes some time. Here already we can see that this 1 message was sent. And yeah, what is a span? So this is our response. and we can actually see that, and if our chatbot is deployed to the users and there are multiple users who interact with it, we will be able to monitor all the messages over here and actually properly work with it, as it is a production ready setup. Okay, at this point we can finish our tutorial. Today we built a RAG pipeline with Langchain and LangWatch for monitoring. We also built a FastAPI server in the backend of our app. We containerized our application with Docker, and then we deployed everything on AWS Elastic Beanstalk. Thank you for following this tutorial, and please subscribe to see more videos on these topics. Thank you for your attention.